All right, today we're diving into one of those really weird, kind of strange what if questions that you might have thought about, but, probably never asked out loud. We're going to use a little bit of science and some basic math to get a real solid answer. So let's just lay it all out there. Here's the scenario. What if you mixed 400 milliliters of urine into 86.4 liters of water? Yeah, it's a bit specific and, let's be honest, a little gross. But the real question we're asking is purely scientific. Is that dilution so extreme that our senses just couldn't pick it up? To really get to the bottom of this, we need to break it down. And the very first place we have to start is with the numbers. We need to understand the scale we're actually dealing with here. So, let's do the math. When you run the numbers, that 400 milliliters and 86.4 liters of water, it comes out to just 0.46%. I mean, that is an incredibly small number. We are talking about less than half of 1%. Less than half a percent is still kind of hard to picture. So think of it like this. It's basically the same as taking a single teaspoon of salt and dissolving it into an entire bathtub full of water. The level of dilution we're talking about is just massive. Okay, so the math shows us the concentration is tiny. That's step one. Now, let's move on to the chemistry. In a perfect world, in theory, what should happen when these two liquids get mixed? And here's the absolutely crucial part. What is it we're actually diluting? Well, it turns out normal urine is overwhelmingly just water. We're talking 95% water. That other tiny 5% is just a mix of stuff like urea, salts, and other metabolites. So when you dilute something that's already almost pure water, it just blends in incredibly well. At such an extreme dilution, all the properties of that little 5%, they pretty much vanish. Any potential smell becomes incredibly faint. The taste gets completely washed out by all that surrounding water. For the vast majority of people, it would be impossible to detect. So in theory, the answer is a clear no. You couldn't taste it. But of course, that's the textbook answer. Science rarely happens in a perfect little bubble. Theory is one thing, but the real world, well, the real world is always more complicated. So let's bring in some real-world factors that could definitely change the outcome. And this is where things get really interesting. In our ideal lab scenario, we assume everything is standard. But in the real world, for one, urine concentration changes all the time. First thing in the morning, for example, it's way more potent. Temperature is another huge one. Warm water releases smells much, much more easily than cold water. And then there's the biggest variable of all, us. Some people have a sense of smell or taste that is just off the charts sensitive. Any one of these things could tip the scales. All right, so we've looked at the math, we've gone through the chemistry, and we've considered the real-world complications. It's time to pull it all together and finally answer our big question. What's the final verdict? So after weighing all the evidence, the scientific conclusion is this. It's highly unlikely. Yes, there are variables. We've seen that. But for most people, under most normal conditions, the dilution is simply too great. It would be, for all intents and purposes, undetectable. Now, before we go any further, I need to get very serious for a moment. This has been a fascinating thought experiment, but that is all it is. This is a critical warning. Please do not ever try this. Urine contains metabolic waste and bacteria. Mixing it into water you might drink is unsanitary, unsafe, and could potentially spread disease. Let's be absolutely crystal clear on why this is a terrible idea. First, it contains metabolic waste. This is literally the stuff your body is trying to expel. Second, despite what you might have heard, urine is not sterile. It can and often does contain bacteria. And third, because of that, ingesting it poses a very real risk of disease transmission. The bottom line here is this is purely for intellectual curiosity, not for real-world experimentation. So we took a weird question and found a scientific answer, and it kind of leaves you with a final thought, doesn't it? If we can break something like this down, what other everyday facts about hygiene and our health might we be completely overlooking? Definitely something to think about. Thanks for jumping into this with me, and we'll see you for the next one.